2, 1. Hello, my name is Mr. Hawkins, and today we're going to be going over converting decimals and fractions, um, converting into either form. So, wow, perfect. Okay. So the first thing I want to talk about is um, the handout you're going to receive in Blackboard. So let's make our way over to that. And as you can see here, um, we're going to be looking at fractions and decimals. So Jackson and Roy each checked out at a lumber store with a piece of wood for an upcoming project. Jackson's plywood was 3 3/5 of an inch thick, while Roy's plywood was 0.7 inches thick. Whose purchase was thicker, and how do you know? Well, the best way to do a problem like this is to get the two problems in a way you can compare one versus the other. So if you get either problem in either a fraction form with the same denominator, a little bit harder, or a decimal form, because decimals are good for comparing, then you can find and easily compare which one is bigger. So what we're going to do is we're going to take this 3/5 and we're going to convert it into a decimal. So you're just going to simply write out 3/5. And we're going to write this as a division problem. Now, if you remember, the 5, I'll make a little arrow, goes on the outside, and the 3 will go on the inside. So we're going to divide 5 by 3, but how do we do that? 5 is bigger than 3. Well, if we can't divide a number because it's bigger than what's on the inside, we're just going to simply put a 0. And this is our ones place, of course, just like normal division. And then we're going to put a point here. But now since 5 can't go into 3, we're just going to add a 0 on the end of this. We're going to say, oh, since 5 can't go into 3, we're going to go to the next place value. So instead, let's see how many times 5 goes into 30. Well, I know 5 can go into 30 6 times. 5 times 6 is 30. So I'm going to put a 6 up here. And then just subtract 30. And since 30 minus 30 is 0, I am done. Easy peasy. So now I have the two decimals, 0.6, and the other one in my problem was 0.7. Now we can clearly order them and say, okay, this is first, this is the biggest one, so this is, I'll put a little up arrow for biggest, big, right? Because 0.7 is bigger than 6. And this is my small, so down arrow. And that is how you do uh, that is how you compare two numbers that don't look the same. So let's go back here to fill in our missing words. To convert a fraction to a decimal, divide the numerator by the denominator. So the numerator, of course, is the one on top. The denominator is the number on bottom. And the numerator, since he's on top, he gets to go inside the little house you make. The denominator's on the bottom, so he gets to go outside. So next, let's talk about the types of decimals we have. We have what are called terminating decimals, which are decimals that end. They're your regular old vanilla decimals. So you could write a terminating decimal as 0.12. Since it ends, it doesn't go on forever, it's called a terminating decimal. So this is terminating. Terminating because it ends. There we go. And then the next kind of decimal we have is a repeating decimal. Repeating decimals do not end. So these could be like 0.3333333, 0.2. Oh, I should just do this. This is better. 0.111111. And that typically, when written in a mathy way, you'll see a little bar on top of the last number. I'm not sure why it changed to yellow. A little bar on top of the last number. That means it goes on forever. So dot, 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 infinity out here. There's still another 3. So yeah, really, really easy to remember. Repeating just means it goes on forever. Terminating means it ends. So let's look at some of these examples. I'll do the first 2, and then I'll leave you guys to do the rest. So our first one is 3/8. So we're going to switch to a new board. And we're going to say, okay, we're going to write 3/8. And we're going to convert this to a decimal. So remember, 3, since it's on top, it goes on the inside of the little house. And 8, since it's on bottom, it goes on the outside. And we're going to say, oh, 8 can't go into 3. 8's too big. So 0. And then I'm going to put a 0 on the end of this and say, okay, that's now my decimal territory. So how many times does 8 go into 30? Well, 8 times 1 is 8, 8 times 2 is 16, 8 times 3 is 24, 8 times 4 is 32, so not quite 4, but 3. So I'm just going to stick with a 3 up here. So 8 times 3 is 24. I subtract, and I get 6. Perfect. So, but since I have a remainder here, I have to keep on going. So I have to put another 0 at the end of here, and I have to think, okay, now I have 6. How many times does 8 go into 60? Well, if I think about it, I say, okay, 8 times 5 I know is 40. Then there's 48, 54, or no, sorry. 40, 48, 56, there we go. And then 64, that would be 8 times 8, right? So 8 times 8 is too much, so I'm going to go with 7. 8 times 7 is 56. And I'm going to subtract. And I'm going to say, oh, 60 minus 56 is 4. I add a 0, and I keep on going. So 8 times 4, or 8 goes into 40 5 times. And once I hit this situation where 40 subtracts 40, and I have a 0 remainder, I'm done. So 3/8 is converted into 0.375. And if you have other numbers with it, you can compare side by side. Okay, so if I'm comparing this to 0.482, well, I can look at this first number and say, oh, 4 is bigger than 3. I know that this is bigger. If I look at it versus 0.374, I could say, oh, 3 is the same as 3. Let's go to the next number. 7 is the same as 7. Next number. Well, 4 is lower than 5, so this one must be bigger. So you could easily compare the numbers side by side and tell which one is bigger just by looking at it. But that's why it's important to get each thing to the same form as the other thing. Let's look at the next one. 1 out of 16. Well, we're going to use a similar methodology here. So 1 divided by 16. Set up our fraction. Remember, 1 is on the inside, 16 is on the outside. And then we're going to say, oh, 16 doesn't go into 1. 16 also doesn't go into 10, so we're going to keep on going. But 16 does go into 100. How many times? Well, that's a little bit challenging, but if you think, okay, 16 times 10 is 160. That's way too much, right? So if you have that, you can have 160 as well. So 16 times 5 is 80. That's closer, right? But we might be able to go a little bit further up. So 16 times 6 is just 80 plus 16, because it's just 16 more than the 5 one. So it must be 96. And that looks like as high as we can go. So we're going to put a 6 there, and we're going to get 4. Okay, well, we know 16 doesn't go into 4, so we're going to put a 0 and do the same thing. So 16 times 1 is 16, 16 times 2 is 32, 16 times 3 is 48, because we're just adding 16s, right? That's too much, so we're going to put a 2. So 32. And we're going to say, oh, this is 8, because we're subtracting. And then we add the 0 to the end, and we're saying, oh, 16 can go into 80. Well, we said earlier that 16 times 5 was 80, so 5. So we are done. It terminates. It ends. Because 80 minus 80 will end the sequence. So we have 0.0625. So that's going to be the answer here. And then this one was, oh, where's my whiteboard? Oh, there it is. 0.375. So that's basically the gist of how to convert fractions to decimals. I'm going to let you guys try 3 through 6 on your own. And we're going to look at the next part of this. So the next part, how long is this video already? 21 minutes, man. Okay, that's fine. The next part of this is to convert decimals to fractions. So to convert a decimal to a fraction, put the decimal over that place value that it's at. So remember how decimal place values work. It's tenths, hundreds, thousandths. It always goes up by 10, a multiple of 10. So tenths, hundreds, thousandths, blah, 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 blah. 10,000ths, 100,000ths, millions, etc. Right? And you're going to reduce until there's until you can't reduce anymore, basically, and that's how you're going to get your fractional form. All right. So convert a decimal to a fraction, put the decimal over not sure what they're getting at here, but I'll show you how to do it. 0.35. So let's look at that, and we want to turn this into a fraction for whatever reason. So we're going to say, okay, I know this is the tenths place, I know this is the hundredths place, so I'm going to put this over 100. And then I'm going to start reducing. So I know both 5 goes into 35 and 5 can go into 100. 5 goes into 120 times. If you've ever played with nickels, 20 nickels makes $1. I don't know who plays with nickels anymore, but you know. And then 5 goes into 35 7 times, because 7 times 35 is, or 5 times 7 is 35. And since 7 is a prime number, we are done, and we are saying, okay, our final fraction is 7 over 20. Let's look at the next one. So we have 0.275. So 0.275. Now think about our place values. So this is 10. This is 100th. And this is 1,000th. Because it goes up by a value of 10 each time. So 1,000th. And I know my writing is atrocious down here, but you know, give me a break here. So we're going to say, okay, this is 275 over that place value, 1,000. And this looks a little bit complicated, but just start reducing and you'll get the right answer. So 5 goes into 1,000. Well, if you remember, 5 goes into 120 times, so 5 must go into 1,200 times. It's just simple little tricks like that, knowing how to do math simple. And if you say, okay, 5 goes into 120 times, so that's 2040. 40 plus what? Well, 75. 5 goes into 75 15 times. So 55 times. And you might notice here, oh, I could have done quarters. That would have been easier. Oh, yeah, I could have done quarters. Oh well. 55 over 200. And don't worry if you don't get it right the first time. Like I didn't get this one right the first time, and it's still going to work out just fine. You'll see. So I divide by 5 again. 55 goes into 5 11 times. And then 5 goes into 240 times. And so I get the fraction 11 over 40. And there we go. I've just converted from decimal to fraction. Perfect, right? So go ahead and try the rest of these yourself. Little thing, well, if you run into a repeating decimal and you're not sure what to do, because it repeats on forever, right? So because this works for terminating decimals, but for repeating decimals, there's just some things you have to know, I guess. So like if you have 0.11111, think about it like this. If I multiply this thing by 2, what will it become? It'll become 2, 2, 2, 2, 2, right? 3, 3, 3, 3, 3, 4, 4, 4, 4, 4, all the way up to 9, 9, 9, 9, 9, right? So I can say that this thing times 9 equals 0.9999. Now the weird thing about repeating decimals is that when you run into a situation like this, 0.9999, and we're going to say is repeating, is essentially 1. And so this thing is 1 over 9, this original thing. So I just kind of gave away 11 and 10, but I'll let you guys figure that out on your own. If the decimal has a whole number in front of it, don't worry about the whole number. Just put that number in front and treat it like a mixed number, and then you can always convert it later. So that's the only thing you need to remember there. Good luck with the rest of this assignment, and I'll try to make my next video shorter. Bye, everyone. Thank you for joining.